Welcome back, students. In this class we continue the matrix and determinants. Next few questions. Here the first question is, let W be a complex cube root of unity with W not equal to 1 and P, that is Pij, that is row and column, be a n cross n matrix with Pij is equal to Wi plus j. Therefore, then P2 not equal to 0 when n is equal to. So we have to find out n here. So P2 is not equal to 0, that is, then we have to find out n. So here the first step is, we have the definition, that is, see, the cube root of unity can be computed by using the algebraic formula. So by using this, the cube root of unity can be computed, that is, a cube minus b cube is equal to a minus b, a cube plus ab plus b square. So the cube root of unity is expressed as, it can also be expressed here in this form, as equal to 3 cube root of unity can be written as a. Again this one can be combined, 31 is equal to a, and further it can be simplified as, that is, a cube minus 1 is equal to 0. So we'll start the problem. These are the n values given. First step is, 4 options are given. First step solution is, first we have to write p square. For p square we have to write, that is, w square, w cube, then w power n plus 1. Similarly for this, w cube, w4 to the power of 4 to n plus 2. Similarly w n plus 1. This continues. Here we have to leave the blanks here. Next is w n plus 2. Then this continues until w 2n. So this one, since it is square, one more p we have to write. Same thing we have to continue, that is w square, w cube, wn plus 1. Same thing, w cube, w4, wn plus 2. Then these are all blanks, wn plus 1, wn plus 2, w2n. So now p square can be written as this one. So combine this, we get how much? First is w4 plus w6, then plus w2n plus 1, 2n plus 2, that is w2 to 4, then 3, 3, 6, then add this, we get n plus 1 will become 2n plus 2. Next is, you can leave some space after this, that is w5, that is this one, 3 plus 2, 5. Next is plus w7, this continues. Next, that is w2n plus 1, 2n will become how much? That is 2n plus 3. Okay, this one, 3, 2 plus 3, 5, 3 plus 4, 7, n plus 1 and n plus 2. N plus 1, this one became 2n plus 3. Next, I'll write here, this continues. Then we leave here the spaces, this continues until the n terms. This one I will continue and write here. Next will be this one, nth term. So this one, last one we'll write here. That is Wn, that is n plus 1 plus, that is n plus 3, n plus 3, Wn plus 5. This one, W square plus n plus 1 will become n plus 3. Similarly, 3 plus this one will become n plus 5, n plus 5. Then this one, this 2, this will become W 3n plus 1. So W 3n plus 1. So this completes. Next, leave blanks for all this, just write down dash dash. Next we'll continue. After this, each term we can write as each term is equal to W to the power of k, we can write into 1 plus W square plus W to the power of 4, this up to n terms. So now again this can be written as we have written the unity form here. Cube root of unity is expressed as, so we can write in this form, that is this W power can be written as W into k. Again this can be split into 1 plus W square plus W into plus 1 plus again once again W square plus W. So this continues, just close the bracket, and hence it becomes 0. You have to write becomes 0. They have asked in the question, if becomes 0, they have asked here P2 is not equal to 0, but we are writing if it is 0 if n is multiple of 3. So therefore P square is equal to 0 if n is equal to 57. So P square will be equal to 0 when n is 57. So next step, and what is the answer? When n is equal to 55, so this is not divisible by 3. So P square is 0 when n is 57. This is divisible by 3. So when n is equal to 55, 56, P square is not equal to 0. That is, this is not divisible by 3 or 58. So the answer here, the option is, that is leaving 57, that is option, answer option 1. Option 1 is which? 55. Then option 2 is 56, and option 3 58 is the correct answer. All the three options are correct here. So leaving that 57 which is divisible by 3, therefore that is P square will be equal to 0. In these three cases P square will not be equal to 0. The question they have asked is P square not equal to 0, what is the value of, that is n. These three are the values of n. So we move on to the next question. That is, a determinant is given here. So we have to find out which is the correct answer here. So now take or substitute anything we can write, substitute or put, you can write A is equal to B is equal to C is equal to 1 here. So what happens, we have to substitute here, that is this becomes 1 square into 1 square, then this is 1 into 1, this one is 1 plus 1. So what happens here, again 1 square, here also 1 square, where 1 into 1, 1 into 1, 1 plus 1, 1 plus 1. Now this becomes, that is 1 1 2 1 1 2 1 1 2. Now just we have to solve this. This one is, that is 1 into, keep 1, 2 into 2, 1 into 2, 2 into 1, then plus this one, again keep 1, then 2 into 1, 2, 2 into 1, 2. So here is, that is 1, keep common, then 2 into 2, then 2 into 2. Therefore finally keep this 2, therefore this one will becomes 1 into 1, 1 minus 1 into 1. Therefore finally we are getting how much, that is here 1 into, that is 0 plus 1 into 0 plus 2 into 0. So everywhere we are getting 0. So 0 plus 0 plus 0 is equal to 0. So 0 is the option. Take 1 here, A is equal to B is equal to C here, 1, substitute here, then write down this determinant and find out the determinant of this, then we will get the answer as 0. So option 3 is the correct answer. So now we move on to the next one, that is the third problem. Third problem is given here. So we have to just find out, this is A and this one is B. This is B is given. We have to find out dA by dx. Therefore first step here is, just take this matrix, this determinant, and just find out x into x square, 1 into 1 minus, then minus of 1 minus of 1, then this one write 1, then x into this one, x into 1, x minus 1 into 1, 1 plus next is 1, we write 1, then 1 into 1, 1 minus 1 into x is x. Therefore we'll get, simplify this, we'll get x cube minus x minus of x plus 1 plus 1, then minus 6. Now we'll simplify, means we'll get, that is x cube minus this one 3x, add all this, minus 3x plus 2. So this is the expression we are getting by simplifying this. So next we have this one B. This is for A. Then we will take B. B is equal to, that is x square minus x into x square minus 1 into 1 square, that is 1. So we are getting B, we are getting A. Now we have to find out dA by dx. So next step is, what is dA by dx? This one is dA, differentiate this one. Therefore dA by dx can be written as, that is this one 3x square differentiating minus 3. So we get 3 differentiating this one, that is dA by dx, 3x square 3. Then substitute here. Therefore dA by dx is equal, this can be written as, that is bring 3 outside, then we can write as x square minus 1. Then substitute B here. See, B can substitute here, which is equal to 3b. So in this option 4 is the correct answer. First take this one, then simplify, we'll get A, then differentiate, we'll get this one. Again B is there, simplify, x square minus 1 we get. Again here take this one 3 common, we'll get x square minus 1. Then substitute B here, so we'll get 3b as the answer. So we will move on to the next one, that is the fourth problem. Fourth problem is so here the matrix is given, then we have to find out a power n here. Therefore first step is a square will find out. A square is equal to a we have, that is 1 0 1 1. Now we'll find out a square. A square is equal to 1 0 1 1 into 1 0 1 1. So now multiplying this one, we'll get, that is 1 into 1 1, 0 into 1 0. Again 1 into 1 1 0 into, again 1 into 0 0 plus 1 into 0 1 into 0 0, 0 into 1 0. Again this one 1 into 1 1 plus 1 into 1 1. Again 1 into 0 0, 1 into 1 1. Therefore this is multiplying, that is a square, which is equal to, simplify 1 0, then this one is 2, again we get 1. Now what is this? Is a square. Now we'll write a we had, we found out a square, then a cube will be, we can write this one in the form 1301. Similarly for a power n can be written as how much? 1 0, in place of this n 1. So now we can write as, next step is n minus 1 into I. So what is I? So n minus 1 can be written as, that is n minus 1. I'll just write here, substitute here, means n minus 1 into I. So what happens? N minus 1 into, what is I? Is identity matrix 1 0 0 1. Multiply this 1, that is 1 into n minus 1 0, then 0 again n minus 1. After this we are getting this one we got, that is n minus 1 into I. Next step is n into, we'll find out n into a. What is n here? So we have n into a is 1 0 1 1. Therefore we have multiply by n 0 n. So now we found out this one. After this, next step is n into a, n into a minus n minus 1 into I is equal to, so we take this one and this one. N into a is this one, n 0 n minus of this one, that is n minus 1 into 0 0 n minus 1. After this, next step will simplify and write directly, that is n minus 1, that is 0 minus this one, n minus 1, then 0 minus 0. Next n minus 0, then n minus 1. Now simplify, n cancels, here also n cancels. Finally we can write this one as, we have 1, we have 0, we have n here, then here also plus 1. This minus goes inside the bracket and we get plus here. So this can be written as, that is a power n. So here option, that is 3 is the correct answer, that is na minus n minus 1 into I. So this is equal to a power n. So this is the solution for the 4 problems. Today in this class I solved 4 problems. If you have any doubt, comment me, subscribe my channel, share and like all the videos. Thank you.